Hello everyone, and welcome into another live stream. And did I mention that I have insomnia? Maybe I forgot, but did I mention that? Did I mention that? Is it something that I mentioned in the... Is it something that I should was maybe... No? Well, here's the thing. Here's the pickle. You see, over the past couple of days, I've had a very nice and lovely sleeping schedule. It was very fun. I was waking up 6 a.m. Felt alive, felt good. And today, well, yesterday and today, both days, I've been streaming the 200 chart checkup, which me and Tefta, we finished it 3 hours ago, 2 hours ago, something like that. Or maybe an hour ago. Hi, the infrared. Welcome. Yeah, I saw your comments, thank you. They had them. I felt I had them. Thank you for the comments, I appreciate it a lot. But here's the thing. Around an hour ago, or 2 hours ago, this is Make It Season 2. It is, yes, it is. Around an hour or 2 hours ago, me and Tefta, we finished streaming the 200 chart checkup. And it's right now for me, let me show you my desktop, my perspective, POV, or make it. Right now for me, it's 3:47 a.m. I'm tired. After an entire day, I'm tired. I love shorts, which is draining my soul and it's not making me feel good in general. I'm really tired. I want to go sleep. But I forgot I have kind of insomnia, that kind of a pickle for me, which means I cannot really. There's nothing I can do about it. So, you know what? Might as well start off the new season of charity checkups with a strong and solid stream. You made your background. Yeah, I dig this. I mean, yeah. Let me close off the thing for a second because I don't want to spoil any new videos for you. Because today we'll be doing cosmos science, planetary science, planetary stuff, physics. But interesting physics. I like this trust me, this will be good physics. So okay, first I have to explain the rules before we can learn why the rules are messy. Blender 3.5, obviously, great for visualizing also things, and save it over here. Ain't rocket science, basic setup. So when you're doing planetary calculations, why are they so difficult? Right, all of them rocket scientists, they probably just sit on their asses all day, they don't do nothing. I mean, come on, there's only a couple of rocks in the sky. How much time, how many hours can you spend just thinking about rocks in the sky? Well, you can spend a lot, but why is that? Why doesn't that seem a bit weird that they have all of this fancy equipment, all of this budget, all of these smart people, and just to think about rocks? Have you played Kerbal Space? I have, but I couldn't understand how to start missions. The rocket building part wasn't the hard bit. The hard bit was understanding what buttons to press to actually start the game. That was the difficult bit for me. But yeah, what, how, where, what now? Okay, first let's go, before I set up the entire project and everything. Oh, dark paint, that looks good. You know what? I like that. It's too bright. Let's do it the other way. Let's do it like this. Let's use a blackboard. There we go. That seems way more fancy and easy on the eyes. So let's imagine that we have a simple system with a sun. All right. F, a smaller dot, and the moon. These are all not to scale and all not. It's too late for anything. That is yeah. I support this message. It not to scale, not to size, doesn't matter. Here's the thing. All of them have different stats, right? 3 stats which we care about. They have, first of all, so all 3 of them, we can actually make it into a table like this. There we go. We have all of them. That's a 4. Make it. Learn how to count. Oh, but we need additional one. Actually, I did it correctly the first time. There we go. So we have the sun, we have the Earth, and we have the moon. And they all have different stats like position, mass, and force acting on them. These are the three bits we care about. Now, what are their position, mass, and force? Well, let me show you, because it is actually pretty fun. It's actually, I'm thinking what program would be the best to explain these for. Okay, let's first imagine that our sun is very massive, and because of that, it's not moving anywhere. So our sun will have a mass of ms. This will be the mass of our sun. Its position will be 0 because it will be in the middle of our solar system, right? Or at origin, it will be 0. And then the force acting upon it will be 0, right? It's just very massive, static, standing there, not doing much. What about F? Well, F will have the mass of, surprise, surprise, the F. Cool. But now, what force is acting on the F? That's a bit more interesting question, and it's actually pretty basic. Looks like this. Force of gravity equation, images, that's what it is. G mass 1 mass 2 d squared. Wait, for 3 masses, do you just cube it? That's from the origin of that equation. Oh boy, that's... Why is there 3? Why is there 3 there? What? Why is there 3? That don't make much sense. Divided by 3. Oh, because that's not how you start. Don't like that. So yeah, it will be d cubed. It will be... Oh, they are added together. That's a mess. So... Okay, let's do the simplified example. So we have an equation for the force of gravity, which, albeit not that complex. Let's be real, we've seen wars. Not that complex. So that's the force of gravity. It is equal to big G, the gravitational constant, distance, alright, between the Earth and the Sun, and over here at the top we have the mass of the Sun and mass of the Earth. That's the equation for the force of gravity acting on the... Yeah, by the way, I was laying in bed and I couldn't sleep because I was thinking about this. My life is sad. Now, what is the position of the Earth? Well, that's really simple, because you see, if we take the equation for the acceleration based on the force, the simple equation, am I right? Simple one, images, then we will see that we have a lovely triangle, and basically, can I get like what would be good for us? Would be good. Average, no, not this. Force is equal to mass times acceleration, which means we have this force, right? Which means force is equal to mass times acceleration, which means acceleration is equal to force divided by mass, which means force of the Earth divided by mass of the Earth. That gives us the acceleration. And how do we get, alright, how do we, can you get the mass of the moon? Alright, in a second. Here's the thing, how do you get the position based on acceleration? It's simple. It's very simple. We'll need to introduce time, but getting the position... I'm not doing the integral right now. I just want the ready answer. Position of an object based on the acceleration. There's a very nice equation in 3 parts. Where's the 3-part equation? I'm looking for the 3-part equation. This one, yes. Oh, why is it written down like that? Oof, I don't like it. No. Well, this, but no. Not like that. Motion of constant acceleration, yes. Where is the equation? That would be way cooler if I already had the equation and I wouldn't have to look for it like that. This. x0, so the initial position, plus v, the initial velocity times time, plus 1/2 at squared. That comes from an integral. You don't have to worry about that. So, initial position is the initial position of the f. The initial velocity would be equal to nothing, because I said so. So this one doesn't matter. So we have the initial position, alright? So the initial position of the f, PE0, right? And 1/2 acceleration times squared. So 2 masses of f, t squared. Dude, congrats, we got an equation for getting the position of the f based on the time. So we give it the time, for example 10 seconds, and it gives us the position of the f after 10 seconds have passed. We give it 20 seconds and it gives us the position of the f after 20 seconds passed. Simple. Now, the question for $1 million, what's the mass of the moon? I know, I'm torturing you with these hard bits. Well, Ali, what a silly guess. That is ridiculous. Mass of the moon, That is, come on, get it together. Don't make me laugh. Obviously, it's the lunar mass. Come on, Ali, get it together. It's sell because you have to sell this idea. Or it's smell because you have to smell this idea. Doesn't matter. So, we have the mass of the moon. What is the force acting upon the moon? Obviously, force acting upon the moon is the gravitational constant, alright, of mass of the moon, lunar mass. This is, by the way, this isn't mass of the sun, this is solar mass. So this, first we have to the mass, the solar mass, so lunar mass, solar mass, that actually sounds pretty cool. And the distance between them, so between the moon and the sun, there we go, plus, added together, I'm pretty certain it's a plus, because it would be as a plus, plus the gravitational constant, alright, ML, between the Earth and the moon, because Earth and moon have their own little lovely bond together. There we go. Yeah, they're having fun. Yeah, there it is. See, it's amazing. These 3 different distances look like this. These are the pink ones right here, like so. These are the pink distances. It's small and sloppy, exactly, but the force acting upon it, and the force it creates, but okay, I'm getting ahead of myself. What is the position of the moon now? Obviously, the position of the moon is calculated in the same way as the position of the Earth. It is force acting on the moon, right, divided by 2 lunar masses, t squared, plus the initial position of the moon. Simple stuff. Initial lunar position, the force acting on the, first six is the lunar force. No one saw that. Absolutely no one saw that. FL because it's lunar. Yeah, you are correct. I fudged myself there. T squared plus PE. I was copying the F one and I saw this as a tilted M. That's what happened. It's not E, it's L. There we go. This time I was actually copying F. There we go. We have all of these equations. Nice, right now, right? You can calculate everything. It's nice. It is nice. It's lovely. Except it is not. Do you know why it's not nice and lovely? Do you know why we're actually being played for fools and this actually makes no sense and is a ridiculous idea? Well, obviously, Obviously, because the equation for the sun is ridiculous. What do you mean the sun position is always 0? What do you mean the force acting on the sun is always 0? Don't make me laugh. That's not what's going to happen. Okay, fill in. How do you do? I don't know. Solid fill. There we go. The black one, if I may. That's more white. I need solid fill. The black. Okay, I need to change second to a black. There we go. There we go. Now, what is the actual force acting on the sun? Well, obviously, the actual force acting on the sun is calculated with a big G constant, right? Solar mass times the mass of the Earth divided by the distance. Divided by the distance of the solar Earth distance squared. Distance squared, if I may. There we go. There we go, that's lovely. Then add it together with what moon is doing to the... Okay, I should add the other way because they are one fit for the... Then add it together with whatever the heck moon is doing to move our solar mass around. There we go. ML divided by the distance. Now we're getting into the really juicy part. Now we're getting into the actual meat and the reason why NASA scientists are sitting on their asses all day, actually doing stuff and not just pretending. And what is the equation for the position of the sun? Well, that's pretty basic. Once again, we copy it. Is the force, the lunar force, divided by 2 masses of lunar t squared plus p of the initial position of the sun. In the Earth equation, we also have to account for how the moon is affecting the Earth force, the force acting on the Earth. So we need the lunar, there we go, lunar m, d squared m l e l. Why m? No, l. It's not Mercury, it's F. And there we go, we have completed our table. But now what's interesting? Do you know what's actually interesting? Take a look at this. This is actually the really fantastic bit. When it comes to these distances between them, right? These distances are dependent on the position. So the distance, the distances are the only things we're missing. Distance, distance, distance. So let's say we are only playing in 1 dimension because it makes things easier, and actually 3 dimensions, that only makes us worry with polygons. No, I don't want to worry that. Let's say it's single dimensional, all right? The distance between, let's do it like this. We have the solar F, F lunar, lunar F, lunar solar, and lunar solar, solar F. The distance between them is the position, the solar position, minus, I'll also fill in the minuses, the position of the Earth. Over here the distance would be the position of the Earth minus the lunar position, and then at the very bottom we have the position of the lunar and sun is the position of the lunar minus the position of the solar. But yeah, this is what I was thinking about instead of sleeping, may I mention. This is what I was thinking about in bed after being awake for 16 hours. Something like that. Wait, 16? Well, no, wait, actually that would be 12. 12 plus 1 is 13, 13 plus... Yeah, 16. 17 right now. 17 hours, that's what I've been thinking about. Now, you know why this is interesting? Because let's check where is Earth. You know what? Let's check where is Earth. It's a simple thing. So, just build different. I am what you call insane. Position of the Earth, equation for the position, because, okay, this is the last bit, actually. This is the last bit, and this will all tie it together nicely. So, the position of the Earth is equal to force acting on the Earth, right? So, position of the Earth is equal to force acting on the Earth divided by two F masses times T squared plus the initial position of the F. There we go. Now, but that's all nice and good, but what is the force acting on the F? Well, the force acting on the F is equal to, we have it over here, so it goes like this. We have two masses of F, T squared plus P, E-O. What's the mass of the F in numbers? It's at least 3 kilograms. Something like that. We don't work with numbers. Ali, don't be ridiculous. Numbers? We have two numbers and both of them are 2. We either multiply by 2 or we square. No, this is real math. We don't use numbers here, okay? We're no longer in kindergarten. This is real. We don't use numbers. I do math which... No, my math does not require numbers. My math is here to make us suffer and regret our life decisions. I will have a joy of animating it. Yeah, I'll make a video about this because let's be real, this is worthy of a video. So, but here we come to the interesting bit because you see the actual interesting bit. Over here you can see that this is the equation for the mass of, for the force acting on the F. ME, and, oh wait, let's add these, and F. You're scared of numbers. Mass of the solar and mass of the lunar. There we go. But now what's interesting is that these distances, right, we can just keep it going. So we do this, and then we copy this bit, because I am not redoing that again. We copy this bit, but now we can see that over here, no, don't, there we go. Now we can see that over here, instead of these distances, we can fill it in even further, and we can fill it in with the equations that these distances are actually equal to. So first we have the F lunar, which will be this F lunar. This is the first one. See, I get the point of all the abbreviations, but there is something so satisfying about plugging numbers and seeing what you get. That is true, but there is a reason why I can't use numbers here. There is a reason. There's actually a neat reason. I'll when I get to my point, if I get to my point at some point, I'll tell you. There we go. So we have this, and then we plug in the other one, which is this one. Like so. Now here's my point, here's my actual point. The only thing that changes for these planets is their position, right? They change their position. But each of these planets' position, because this, if may I remind you, is just equal to the position of F. So in order to check the position of F, you need to know the position of Sun and the position of the Moon. But in order to know the position of the Sun, you need to know the position of the F and the Moon. In order to know the position of the Moon, you need to know the position of Sun and the F. And this is, well, if you think, the more you think about it, the more bizarre it is, right? So, in order to get the position of the F, like, really think about that for a second. Sounds like geometry in triangles. That's the key. It's not. You cannot resolve it with geometry. Think about it. The position of the F is some function of position of the Sun, solar position, and, let me just green, there we go, and lunar position. Whilst at the same time, the position of the rest, like this is dependent on the position of the F, and this is dependent on the position of the lunar, like this. Do you see how bizarre it is? You need all of them. Think about this for a second. About this bit right here. Think about it for a second. Think about how ridiculous it is. You have 3 unknowns, and each equation is dependent on the other 2 unknowns. How would you go about solving this? How would you solve this? I mean, Sohcahtoa. No, it's not quite Sohcahtoa, because this. Look at that. Let's say you want to solve the solar position, right? Solar position then would be equal to the force, right? And in here we want to plug in the position of the F. So the position of the F is equal to function, right? And solar position. But what's the solar position? Well, solar position is dependent on this, which means we plug in the yellow function, to which we then plug in the green function. And then we keep on going. Then we add a yellow function because we want to find out solar position. Haide tefta! And then we want to find out the F position. And then we keep on going. Because you see, then we add this one, and we keep on going forever. It never ends. It's an endless cycle. I really want to give you a second to appreciate just how astonishing it is. It goes on forever. It never ends. It's the same thing over and over again. So you can't solve it this way. I feel like a mad scientist, honestly, right now. Even though I'm not. It's basic math. Not basic, but it's actually a reason for why calculus is cool. Oh my goodness, I've given away the answer. Yes! The answer to how to solve it is calculus. That's why calculus is such a cool tool. Because it allows you to solve things like these. I won't show you. I will not show you how to solve it with calculus because I do not know. I do not have the skills required to solve it with calculus. But calculus gives you the tools required. Because think about how would you go about solving these. Imagine, okay, here's like a not quite the same example, but kind of. Imagine that you have something, a set of equations which looks like this. Alright? We have y, which would be equal to, let's say, times, and then you have, well, not times, but I feel like we should do, all of them are the same operation after all, and x, y, z. How would you solve this equation? Is that really not sine, cosine, tan? No, it's more like this. Take a look at this. How would you solve it? It is the same scenario, except without any functions, because yeah, I know, they make things look messy. This is a very simple thing. There's only addition involved. Nothing else. Only addition. How would you solve it? It's tough. Minister have taken calc instead of limit stuff. No, I don't want to, talk. No, I'm not here to actually give you an actual course for calculus. This is more of a live stream of why calculus is useful than, because here's the thing. There is a difference in between understanding calculus and knowing calculus. Substitution. All right. Yeah. Logical. Logical, very logical, because, yeah, it's addition, obviously, would solve with substitution. So let's solve with substitution. We have z, yeah, blue. I mean, I know my colors. Okay, I may know calculus, but I still mistake colors, right? They are harder, one level higher. And x plus y. So let's first substitute x, right? Substitute, all right, cool. Is equal, I think I screwed myself over because I think this is solvable, because I gave away the function working on them, so that might be solvable. I think I gave away all the... I'm pretty certain I screwed myself over on this one, because then you will have y, yeah, that looks very solvable. Y plus... Oh, maybe it isn't? No, I think it is. Plus z, and then y, so we can just keep the y. So blue plus y. maybe it isn't, because we still get an equation of z is equal to, well, we get an equation which gives us 0 is equal to 2y. So I screwed myself over by giving away the function. Yeah, obviously there's a solve to it. If all of them are equal to 0, they obviously make sense, and they have to be equal to 0 because otherwise they would spiral off to infinity. So that was a shitty example, make it. Good job. That's why they are doing these science calculations to get stuff on the moon, and you do YouTube videos. And in the actuality, it would be more of a uneasy, but me see it better. Just calculate the trajectory of the thingy. That's exactly. But that's what's amazing about this, is that when it comes to stuff like these, there is some way to simplify it so that you only plug in the time and you get everything you want. You plug in the time and you get the position of every single planet. You plug in the time and you get the force acting in every single planet. But it is possible, it definitely is possible. That function exists. We know that because in our reality, we do have time, and in every single different time, different forces are acting upon different planets differently. So we know that these equations exist, but getting them is hard. That's calculus. That's how you do things with calculus. I feel like it's still not quite as clear cut as it could be. It feels good to like kind of. It really feels good to finally put it on a piece of paint. I had this in my brain. I couldn't sleep because of that. Maybe I don't have insomnia. Maybe I'm just. Maybe I have OCD. Alright. Any question? Well, there are many questions, I assume. But first, which one first? If you have the energy to ask it. The biggest issue of that is that I kind of. Yeah, the biggest issue is that they didn't paint. That's the biggest issue. I didn't do it in paint. Maybe in some sort of professional thing for math, then it would be more clear cut. In Manim, if I did it in Manim, that should be more clear cut. But that would take a lot of animating. 30 minutes. This was actually a really good stream, you know. I think this is the first time when I did a 30-minute long stream, of which I'm actually proud. That was a really good stream. Yes, I think so. It was pretty entertaining for me. But, you know, at the same time, I am here because of mental disorder, so I might be ever so slightly not quite as objective as I should be. So how is your day going? How are you all doing? Tefta, I know. I know Tefta. I feel like we kind of talked for like 8.5 hours yesterday for me, today for you. Get the double check out the day. Well, tomorrow. The time is relative. Oh, do you want me to explain to you why time is relative? Or is it enough math for it one day? The thing why time is relative, that's actually is a very beautiful thing in physics. I like it a lot. I should get a hobby. Oh yeah, that's my hobby. I should stop getting hobbies then. I think because of the grenade clip. That was really yeah, I'm not going. I'll throw a Molotov. Tefta. That's a grenade. It was pretty comical. Okay. So, 3 people watching. How you all doing? No, math is over. We can watch Tefta's clip.
Oh my goodness, that's futuristic. Ooh,
that's a change.
that's cool.
Oh no, that's not futuristic.
Oh,
that's
babies.
lamps from... Oh no, it is futuristic. That's a lot of babies. Kill the kids! Is that the... That's a shovel!
Ah,
We
sweet.
got a shovel, Tefta! Oh,
Finally.
So oh, there's... Yes, oh my goodness. Yeah, there are two double mutants guarding it. But it was worth it. Okay, let's
Okay,
do one.
okay, I need to jump. I need to jump and maybe to Molotov them.
Yep, sounds good.
I Molotov
Oh
them.
my goodness, what was that?
I Molotov them.
That was a grenade.
Oh, okay. Grenaded them.
Pick me up.
Yes, I used.
Well, because
Oh, wait.
it was very comical on my side. I don't know how late it was in the stream. It was... I'm pretty sure that was right before Ali joined. I remember that. We were leaving that cave when Ali joined because there was the two short things. So someone subscribed to me on the beginning of the stream, by the way. Someone subbed to me right when the stream started. Boy, are they going to regret it now. So it was like this. Do I have a chat playback? No? I don't have that access to that sort of technology. That was 6 hours in, right? Yeah. 5 hours.
And there's lots. There's more on the other side too.
It's
Top.
killing kids, so 39. All right, on it. For you by 3 minutes. That was more. I wasn't wearing it to be fair. I don't know which way. Right, had the money, but then there was also a paddle to which even you go. That's all right. So forward, got it. As I said, as I mentioned, time is relative physics stuff, and yeah, there we go. The kids are honestly worse than the big mutant thing.
Yeah. Okay, I am totally close to death.
Me too, but I'm dooming it. Right
Oh,
now.
I died.
So it was before. Oh yeah, ignited with Molotov after, yes. That was... that was a grenade. Indeed. But it was worth it. Okay, let's focus on that's my perspective. That's
Okay,
what I basically saw.
I need to jump and maybe to Molotov them.
Yep, sounds good. No, I also have a Molotov binded. Oh my goodness, what was that?
Molotov them.
It just blew up and I just went a couple of feet higher. I wasn't I'm not used to seeing the world from that perspective. Also, I forgot to mention that, but you made the thumbnail, you made first of all, you made an objectively better thumbnail, but also you photoshopped the image of me and you together, right? And I just wanted to thank you for making me taller. First of all, than I actually am, and second of all, I'm just tall. I like it. I like this thumbnail. Look at that. Look how tall I am. I like that. In real, don't ever trust the height of someone you see on the internet. They are always short, always. If they are on the internet, that means they are short. So no? We're good. It's all, yeah, cool. I feel like I got an idea for it months ago when I was watching Love a Short King. Yeah, I am your lord. Yes, that's an appropriate title. I may be a king, but you may call me lord. Yeah, I feel like the coffee isn't helping my insomnia one bit. I haven't drunk any for the last 3 or 4 hours of the stream because I knew I had to go to sleep later. So I had to finish it now. Yum. So if there's any more math in the future you'd like me to explain with you can be a king, but watch the queen conquer Nicki Minaj. Well, isn't that the song? Should I listen to it? Something? Or can I even play it on YouTube? I don't want to get demonetized. Oh wait, I am not monetized. I forgot. Honestly, I'm more of a. Listen, I'm not really into he, him, or she, her. I'm more of into they, them, stupendium, king, kind. I'm more of a stoop gang person myself. So yeah. Oh yeah, I also set up Blender because in the beginning I wanted to kind of add an empty. Where is it? Empty. I'm quite nauseous to come up with theoretical math equations. That's the thing when it comes to. That's what happens to me. When I'm not tired, I walk. When I am tired, I do science. Science is the reason why I don't need to drink. All right, I just have science. That's enough for me. Look at that. If I bind this to this, right? If I move it up to, if I bind this to this with a Control P object, if I bind this to this Control P object, then if I keep other location rotation and then I rotate it by 180 or 360, sorry, I don't know angles, there are too many angles, and then I location rotation, there we go, then this will not rotate because Blender isn't that great at 360. That's how I'm supposed to do it. I'm an idiot. The fact that I still haven't figured it out is, there we go. And then if I rotate this 360 and, well, 0. I don't need alcohol, I have science is a great, actually, slogan. Well, you're already in the wrong way. Oh no, wait, you're not. There we go. Look at that. Now if I only would set it to linear, I had no idea how, but it's probably graph editor, I'm guessing, higher up, and this, instead of interpolation Bezier, linear, like so, and top one linear. But it doesn't work. Right click, no. How, why, how do I, when, and where, and whom, with whomst, by where, whenst. Drivers, maybe. No. This, yes. How do you, no. White, wait. I have no idea how to do it. I did it once, it worked. But not great, not well. Inflation, no. I should end the stream, right? Shouldn't I? Yeah, I feel like that'll be it. It's a good one, 43 minutes, yeah. Honestly, I feel like it was a pretty good one. I feel like I've said enough. I'm off to work on the video instead of sleeping, because, you know, sorry about. For now, that'll be it. Thank you so much for watching and have a great day. Bye!